Our objective for today, I can solve a system of linear equations by graphing. Let's read it together. 1, 2, 3. I can solve a system of linear equations by graphing. Let's read it again. 1, 2, 3. So today we're moving on to a new concept, and the concept for today is systems of linear equations. We already finished, from the beginning of the year, expressions. Real numbers, expressions. We went into polynomials. From there, we went into one variable equations. From there, we went into multi-step equations. From there, we went to inequalities. And then we moved on to two variable equations. Is that correct? Now we're going to move into systems, now that we're done with simple two variable equations. So what are systems of linear equations? Systems of linear equations are a set of two or more linear equations that have the same variable. A system of linear equations are a set of two or more linear equations that have the same variable. Systems of linear equations are a set of two or more linear equations that have the same variable. Systems of linear equations are a set of two or more linear equations that have the same variables. A system of linear equations are a set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. A set of two or more linear equations that have the same variable. Tell your neighbor the definition. A set of two or more linear equations that have the same variable. So examples. Bracket, such as like a solution set type of bracket, and then you're going to write y equals 3x plus 1 and negative 4x plus 2y equals 6. Y equals 3x plus 1 and negative 4x plus 2y equals 6. All right, writing utensils down really quick. I'm going to give you time to copy because there's some more examples, and I'll have you copy the rest. Writing utensils down really quick. Gianna. Thank you. Here we go. According to the definition, it says a system of linear equations is a set of two or more linear equations, and they need to have the same variable. Let's see. Do we have two equations or two or more here? Do they have the same variables? Yes, y and x, x and y. They might not look the same because one of them is one form and another one's a different form, but they are linear equations. Let me give you another example. Look at this one. Do we have two or more linear equations? Yes. Do they have the same variables? Yes. What do you notice different this one from this system? It doesn't have the bracket. Some books are going to present it like that. Some with brackets, some without brackets. So that's why I'm showing you both ways. There's no difference. It's still a system. Because what is the definition? They have to be two or more, and they have to have the what? Same variable. Look at this one. Negative 6x plus 3y equals 12. 4x minus 3y equals 8. It's also a system. Everybody understand? Okay, finish copying that. I'll give you guys some time. Let's go to non-examples. Non-examples. Look at this one. Y equals 1/2 x minus 2 and 4a plus 2b equals 12. As you're writing it down, fill in the blank in your noodle. Don't say it out loud. This is not a system because blank. Okay. Tell your neighbor, please, why that's not a system. Okay, volunteer. Yes, Dallas. They don't have the same variables. It's two linear equations, but they have different variables, x and y, a and b. Now let me show you another non-example. Look at this one. Y equals negative 2 plus 1/2 x. Tell your neighbor why this is not a system. Boss, why is this not a linear equation? It doesn't have two or more what? It doesn't have two or more linear equations. That is correct. Everyone understand? So therefore, now that we know that what these are, so what is the most important thing to remember about systems? That they are what? Very good. Write those down, please. Copy that. So now that we got the concept down, let's look at the steps. It's only 4 steps. Copy these down, please. Step 1, solve for y. What does that mean? We need to write the equation in slope-intercept form. Step 2, graph each equation. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Step 1, solve for y, which is what? In slope-intercept form. Step 2, graph each equation. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Step 1, solve for y. Step 2, graph each equation. Step 3, identify the point of intersection of the lines. Step 4, check your solution and graph your line. Write your statement. Step 1, solve for y. Step 2, graph your equations. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Step 1, solve for y. Step 2, graph your equations. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write your statement. So now, as we continue getting to some of the processes that are going to require a lot of steps, some of us have a difficulty remembering steps. So, what I do every year, I give students maybe some signs that you can use to remember the process. So, step 1 for solving, I do this. I tap my tempo over here like this, like if I'm thinking. Because what do we do to solve? We think, right? Solve for y. Step 2, graph your equations. Step 3, identify the point of intersection of the line. Right? Get it? Step 4, check your solution and write a statement. Here it goes again. Step 1, solve for y. Step 2, graph your equations. Step 3, identify the point of intersection of the lines. Step 4, check your solution and write a statement. Simple? Tell your neighbor the steps without reading. See if you got them. So, we got our 4 steps on the big graph. Get the big graph in front of you, please. On the top left, copy this example, please. Example 1, it says, write the instructions. On the top left corner of your big graph, it says, example 1, solve the system by graphing and check your answer. System given is y equals 1/3 x minus 3, and the second equation is 2x plus y equals 4. Copy that, and then we'll do this one together. Okay. Now, this system to solve, today we're going to solve it by graphing. Now, individually, the equations, we already know how to graph. We already know all the processes. Today, they're just going to come together. They're going to mesh together. You're going to see how it works to solve a system. So, step 1 was what, boss? All right, let's look at the first equation. Is it solve for y? Yeah, how about the second one? No, so let's do that, and I'm going to do that in red. If you have your pens, get those ready. So I'm going to do this one in red, solve for y. Everyone, what is my first step to solve for y here? Subtract 2x, subtract 2x. We're left with y equals negative 2x plus 4. And why did I write it like this? Because we need to leave it in slope-intercept form. Step 2, Mia. Graph the equations. So I'm going to start with the top one, this equation, since it was already solved. I'm going to graph this one in blue. So what information do I need from this equation to start graphing? the b, which is -3, that's my y-intercept. So plot that, -3. And my slope tells me that the rise is 1 and 3 to the right. 1 up, 1, 2, 3 to the right. Do it again. 1 up, 1, 2, 3 to the right. Do it again. 1 up, 1, 2, 3 to the right. And graph your line. Make sure you, if you don't have a ruler on your desk, go get a ruler. They should have left the ruler on your desk. Make sure you extend all the way across the coordinate plane, because you sometimes the intersection is far off from one quadrant to the other. Okay? So we're done graphing that one. Let's graph the second one. I'm going to graph the second one in red. Where do I start on the second one, everyone? Y-intercept, which is 4, positive. So I circle it. I plot my point on 4. There it is. And my slope tells me I need to write it in fraction form, which is -2/1. So the rise is 2, and it's going down. So 2 steps, 1, 2, 1 to the right, plot your point, do it again, 1, 2, 1 to the right, plot your point, do it again, 1, 2, 1 to the right, plot your point, do it again, 1, 2, 1 to the right, plot your point, do it again, and so on and so forth. I know, right? That, it's already on YouTube? Oh, yeah. No.
It's gonna be on YouTube. It's gonna be viral.
All right. Yes.
You say that? Leave a like, thumbs up, subscribe.
All right. So step 1 and 2 are done. Step 1 was to solve for y. Step 2 was to graph the equations. Did we do that?
Yes.
Step 3. Santi. Identify the point of intersection of the lines. Does everybody see the point where both lines intersect? Circle that point, like so. I'm doing this with green. I'm pointing a little arrow to it, and I'm going to write the coordinate. And everyone, what's the coordinate of this point? 3, -2. 3, -2. Above that, put a little asterisk, and you'll see why. This is the possible solution. Now, why do I say possible? Because sometimes some of us make mistakes with our graphing. Who's made mistakes before? I made mistakes, so you better raise your hand. So, to check to see if that's the actual solution, we need to go and check each equation. So I want you to write the first equation on the left, y equals 1/3 x minus 3. I'm going to write side by side the other equation, which is y equals -2x plus 4. Now, when we were in one variable equations, we would just substitute one value to check. Is that correct? But now how many values do we have on this point? 2, an x value and a y value. So what is my x value? 3. So here instead of x, I'm going to substitute in there 3. And instead of y, I'm going to write -2. Bring down everything, equals to 1/3 times 3 minus 3. So what is 3 times 1/3? 3 over 3, which is 1. Bring down the -3 and the -2. What is 1 minus 3? -2. Is that true? Yes, that's true. Let's check the second one. We said that x was 3 and the y was -2. Bring down the rest. So let's see. What is 2 times -3? That's -6. Bring down the 4. What is -6 plus 4? -2. Is that true? Yes. So what did we find out? That is a solution, right? So now we go back where we put the asterisk and we're going to write solution now that we checked. Now let's write our statement. The solution to the system is 3, -2 because it's where both what? Lines intersect. That's one because. What is the second because? And how else do we know that that's a solution? Yes. Bam. And both equations are true. 10Q. Intersect. The solution of the system is 3, -2 because it's where both lines intersect and both equations are true. Does that make sense? And when we get into word problems, you'll see how this statement is going to start making a little bit more sense. But for right now, we're just graphing and solving from the graph. Are we there? Okay. So now that we have that, let's go through the steps to make sure we got all the process. Step 1, did we solve for y?
Yes.
Step 2, graph the equations. Step 3, identify the point of intersection of the lines. Step 4, did we check and did we write our statement? Yes, that's the process. Now let me ask you this. Step 2 was to graph the equation. Look up to the screen. To graph the equations, how many different ways, think about it, do we know how to graph an equation? Tell your neighbor the 3 different ways that we know to graph equations.
That one, the one with the X and Y.
Okay? Let's see, who can elaborate on this? How many different ways do we know how to graph? Who said 3? Julia. What are the 3, Julia? Or give me one of them first. The Q way, which is, the cover method. So using the what? The X and the Y intersects. Does everybody remember that? So could we have covered this X up? Look up, please. This one?
Yes.
And what do we have left? Y equals 4. Is it at 4? Yes. Could I cover up the Y up here? Yes, and I'm left with 2x equals 4 divided by 2. That's x equals 2. Is it at 2? Yes, and then graph my line. Does everybody see it? Bam. You're like, what?
Shortcut.
Does everybody see that? Okay. The reason that today I'm actually giving you the process to solve for y and use the slope-intercept form so that we all start at a beginning point, but then if you can see that you can graph it whichever way you want. If you want to use a table, use a table. If you want to use the intercepts, use the intercepts. If you want to use a slope-intercept form, use that. Does everyone understand? Yes.
And the party, do we have to do it this way?
For right now, for the home plate, this way. But then afterwards it's going to say solve the system by graphing. You can do it whichever way. Does everyone understand? All right, let's move on. Let's do one. I'm going to get you started with the next one. Copy this one, please, and turn the paper over to the medium size. Right now we were in the big one, right? Okay. So copy this one, please. Example 2. You don't have to copy the instructions. You already have them. Here's the system. Y equals x, and y equals negative 2x minus 3. So, y equals x, and y equals negative 2x minus 3. Let's see. Step 1. Voss. Okay, everybody look up. Are they both solved for y? Step 2, everyone. Graph. So let's start graphing the top one. We're starting with the red. I'm starting with red, this one. What information do I need from here? The B, which is the y-intercept. So what is the y-intercept? 0. So you put plus 0 and you plot your point right there. What is the other information that we need? The slope. What is my slope here? 1, which is 1 over 1. That means one step up, one to the right. So then you go one step up, one to the right. Plot your point, do it again. One step up, one to the right. Plot your point, do it again. One step up, one to the right. Plot your point, do it again. One step up, one to the right. Plot your point, do it again. And graph your line. Do that in red. Now that I helped you with that one, I want you to finish up the rest of the process. Graph the other one and finish all the steps by yourself. See what you get. Go. Copy that and go. Okay, let me see the graph to see if you're on the right path. On this one, we started with -3, and the slope was -2 over 1. That means 2 steps down, 1 to the right. Plot your point, do it again. 1, 2, 1 to the right. Plot your point, do it again. 1, 2, 1 to the right. Plot your point, do it again, and so on and so forth, right? Step 3, identify the point of intersection of the lines. It's about right there. Hands if you got -1, -1. That is correct. That's a solution to the system. And you checked and you write your statement, right? Okay? Everybody got this? Okay, this next one you're going to do by yourself. I'm not going to help at all. See if you got this by now. Okay, do it in the other. Thank you. Here we go. Example number 3. It says solve the system by graphing. Check your answer. You don't have to write the instructions anymore. Use the second medium-sized graph for example number 3. And the system is y equals x minus 6 and y plus 1/3 x equals -1. Go. Copy that and solve. Sorry. So the first step was to solve for y on this one. Minus 1/3 x to each side. And some of you were asking, Mr. Q, so where does the negative go? Always when there's only one negative and we're graphing, make sure you attach this to the numerator. Right? We know that goes with the rise. So the rise is what? 1 down and 3 to the right. So that we're starting with the y-intercept, which is 1. 1 down, 3 to the right. 1 down, 3 to the right. So here's my graph. And the more points you use, guys, the more accurate your answer will be. For those of you that only use 2 points, maybe your answer is not going to be as accurate as it should be. Okay? Let's go to the second one. The second one I'm going to graph in blue. I start at -6. Whoa, where's it at? Yeah.
Does it matter which one you put the negative on?
No, as long as you know if it's a negative for the whole thing that it's going down, that's fine. So, -6 is right here, and then it's 1 up, 1 to the right, 1 up, 1 to the right, plot your point, do it again, 1 up, 1 to the right, plot your point, do it again, 1 up, 1 to the right, plot your point, do it again, 1 up, and so on and so forth. So here's your equation, and there's your graph. And it looks like, let me move this up a little bit. About right there. So my point of intersection looks about right there. Where are we on the x? It's about what? 3.5. So 3.5 guesstimation. Yes. And what is our x? Our y? negative 2.3, negative 2.5. I'll take either one. Does everybody see that? Let's see, what kind of numbers did we get? Yeah. 3.7, negative 2.3. Okay, negative 2.3. All right. Yeah.
3.5, negative 2.5.
Negative 2.5. I'll take that also. Yeah. And so on and so forth. Yes? How are we doing? Good? All right, so let's close this lesson so we can move on to our warm-up. So really quick, here goes a question for you. And turn over your Cornell notes to the summary section. Your Cornell notes. At the bottom you have a section for summaries, right? Question. What does the point of intersection of two lines mean? Talk it over with your neighbor, and then once you come up with a answer the question there on the summary section. Go. Okay, who can elaborate on this? Let's see, Sergio, go.
They're not parallel. They cross each other when they're like.
The point of intersection where they cross each other, okay. But what does it mean?
When the two lines go a different route.
That's a slope. That's the one that gives us a different direction. What does that point of intersection mean? You can elaborate. Yes, Auntie? It's a coordinate, of course, because it's a point. Yes? It's the X and Y, and we use that for substitution. Okay. But what does it mean? Somebody walks in right now, and they see you graphing, and they're going to ask you, what does that point mean? What would you say? Yes? It's a solution. And how do you know that? It's a solution because it's where the two lines cross. But how are you sure that it's a solution?
Because you checked it.
Because you substitute and you into each equation, and it makes each equation true. Write that down. My goodness. So write your thoughts for that on that. And just a reminder, our home play for tonight is on pages 281 to 282. All right, guys. Enjoy your home play. See you guys tomorrow.